Okay, so thank you everyone for joining me. It's kind of weird saying this to an audience that you can't really see. Usually at conferences we would, look at everyone in the crowd and just say hello to everyone. So thank you for joining me. Either way, I hope you're all staying safe at your homes or wherever you are currently. My name is Filip Babić, and I'll be talking about the story behind my thesis project, or a library which I developed in open source. Well, currently only developed by me, but I'm just looking for more people to work on, which is called Li, and it's a library about accessibility in Android. If you don't know who I am, just a second. If you don't know who I am, I'm currently working as a video instructor at Razor, which is a company behind the raywen.com website. We're a really big educational portal where you can learn all the things about Android, iOS, Unity, server-side Swift, and some other things. I've been developing in Android in the Android platform for about 4 or 5 years now, since 2015, basically. And I've been doing lots of content creation, so podcasts, books, authoring tutorials and articles, and now video courses. As you can see behind me, there's a green screen and everything. And I'm also a Google developer expert and have been since 2019, and I've been an expert in the Android and Kotlin categories. So if you want to reach out in terms of any kinds of things regarding Android or Kotlin, or any kind of content creation, you can do that. And I'll share some of the links where you can reach out to me later in the presentation. But today we are not here to talk about me as much as we are to talk about all of us as developers and generally the entire community we have and the user base we have in Android and in mobile development overall. So one of the things that really hit me this year and last year actually is that more than 15% of the world has some kind of disability, meaning that you either suffer from some sort of visual impairment, hearing impairment, or even some kind of muscular or just body physical disability that stops you from doing the things you love in the optimal way, so to say, or maybe even completely. So as you can see, I'm wearing glasses, but I don't have such a big disability that I can't do the things that I love. But some of the people that we develop applications for have maybe total visual loss and can't use their applications as they would like. So when you take that into account and also take the number of 2.5 billion people who use Android as their primary OS, which was a statistic from last year, so it's maybe even over 3 billion people now. There's just a huge number of people in our audience that have some sort of disability, hundreds of millions, which means that the applications we build may not be as accessible as we think they are, or the target audience we have, the average or the ideal audience we have, might not be as able to use our applications as we would like. And just by looking at the fact that a lot of our users have some kind of disabilities, that it means that our applications might not be usable for them. It means that the way we develop applications might have to change to accommodate for those numbers. And this is kind of what software accessibility does. This is a way to defeat those numbers. So using something called software accessibility, or just in general accessibility, we can make our applications more usable or easier to use for people who suffer from any kinds of disabilities. So if you're not sure what software accessibility is, it's a way to develop applications, or in general, accessibility is a way to develop any kind of product that is more inclusive and accessible to people who suffer from visual, hearing, or any kind of other impairments. So one of the ways I think about software accessibility is, when you talk about applications, we all often talk about the UI and UX of applications, or the user interfaces, or how the application actually looks, and user experiences, or how the application translates to some kind of experience for the user, or how the user uses that application to achieve some behavior. And we often think about applications and develop them in a way that they are foolproof, meaning that if your average Joe or average user who might not be as tech savvy opens your application, they should be able to use it without any special instructions, or just you having to hold their hands and lead them through the application. So, for example, if you open up Netflix or Messenger or any kind of other applications which are really, really common nowadays, you more or less know how to use them out of the box, or you can find like an intuitive niche to it where you can lead yourself through the application by using experience from previous applications. And this is what it means, that applications are foolproof now, that even though you might not be able to, or you don't know how the application works before running it, you will be able to use it because of previous experience. But this doesn't go so well along the lines of disabilities and accessibility, because if a person cannot see completely, or cannot see at all, it doesn't mean that because of their previous experience with that condition, they'll be able to use your application now, which requires a lot of visual feedback and a lot of feedback from the user to actually use the application, which means that we don't really think about applications as being disability proof. And accessibility, or ALI, or A11Y for shorthand, is a way to support all these people when it comes to using our applications. So what is accessibility in general, again, and how do we do it? Well, it's just a set of rules, a set of guidelines to develop applications, user interfaces, and user experience to support different kinds of modes in your applications. So similar to how I mentioned, UX guidelines help average people navigate your app. Accessibility is like UX for people with disabilities, a way to help them navigate your app and use your app. So some of the modes and some of the ways you can see accessibility in applications or software nowadays, or even some modes that you can support yourself through applications, is by using some kind of UI scaling or voice assistance to go through the application and make the content more visible, so to say, for people who suffer from any kind of visual impairment. Also, you can use screen readers, text-to-speech, and speech-to-text, which is like a reverse way to either talk to the application and then write some content, or read the content from the application out loud for people who just can't see it or can't differentiate between, let's say, different colors or different textures in the application, or have a really strong impairment of sight where they just can't see the content you're trying to show them, like images. So all of these modes and some of the others that I mentioned here are used to help those people use your applications, and they are generally supported through every single operating system. That means iOS, Android, Windows, Linux, macOS, any kind of operating system you might be using nowadays, and even through web-based applications, which are not an operating system on their own, but they're a special type of software that we use every single day. But the problem is that not every application supports these modes, even though they exist in the operating system or the platform we're using. And this is where my library or some of the other libraries come in. But before we dive into my specific library or my project that I worked on, we can take a look at the Android side of things, because I'm primarily an Android developer, to see what kind of other libraries and solutions we have. One of those solutions is the Accessibility Scanner application and framework, so to say. It's an external application that you install, and where you can draw over other applications and take screenshots, which means that you run the Accessibility Scanner application and you run your application, you take screenshots of the app, and it gives you a report of all the issues you might have in terms of accessibility. And this is what it kind of looks like. This is the Ray Wenderlich or Ray's Emitron application that we use for our video course, which is also open source. And basically, you can tap on specific elements, you can go through the application, and then by doing so, you can see which issues you might have in your application, be it the textual contrast not being high enough, so the users might not be able to differentiate the text from the background, missing image content descriptions, and different things. But the issue with Accessibility Scanner is that you have to do a lot of manual work just to get it running, and then screenshot all your screens, obviously, and then do the analysis, which is kind of boring. Well, not boring, but tedious, and takes a lot of work, which is why you have something else called Accessibility Test Framework, which is a suite of testing tools. So a suite that supports unit testing and Android UI testing, where you can run accessibility checks in each of your tests, meaning that you can automatically support any accessibility checks. And if there are some issues in accessibility, your tests fail. But this means that basically any small issue with accessibility will fail your tests and possibly could fail your builds, which means that it might slow down the entire build process. So what accessibility test framework does is it allows you to suppress some specific checks for specific views or specific types of views, which means that if you are in a hurry to get a build out, you can push that build out through your CI/CD instead of failing the tests and failing the entire builds. And it's really easy to use, but again, it takes a lot of work because you have to write the initial tests to run the accessibility checks on top of them, which is, again, a lot of work that you have to do manually. And this is where my library or my thesis project comes in, which is also called Ally, but it's the library name and not the actual abbreviation. And it's an open source library that's supposed to give you all of these checks and all of the accessibility support in your applications without actually requiring of you to do any work. I generally think of it as LeakCanary for accessibility, where you plug in a library and it does the analysis and the scanning of your UI in runtime instead of you having to do any extra work like writing tests or doing screenshots of your application. So it basically scans every view in your hierarchy, giving you a report on all of the things that you fail to support in terms of accessibility, or that things like warnings or just general suggestions of how you should do things. For example, to have your font size big enough for people to be able to read who might have some issues in terms of their visual impairments or something like that. And it's not just about scanning the issues. It's also important that you report them. So what I do in the library is in every onDestroy callback of fragments and activities, I scan or I take the view, the root parent or the root view of the activity or fragment that are visible and being destroyed. I scan its hierarchy, and with those scans results, I generate a complex report, which gives you a lot of information of where the issues lie, what the issues are, and how to fix them. So it's like a way you can think of the library as a true ally, someone who's trying to help you out to achieve better results. In this case, achieve better results in terms of accessibility. So some of the issues that Ally detects and some of the things that it can do is it can detect a lot of textual issues. So things like the textual contrast towards the background of the actual text. So for example, text hues, buttons, and similar. It scans text sizes and autofill hints and general hints for edit texts. It also scans general issues such as image view descriptions, which might be missing or might be not optimal, so to say. So wrong descriptions which contain redundant content and just don't really tell the user what's behind the image. And of course, view, touch, and size areas, meaning that if you have a view which should be able to receive clicks or touches, then you should be able to have a big enough view for users who have maybe some kind of physical disabilities to be able to use it still. And that's not always the case, of course. One of the disclaimers here is that the library is not 1.0, so there's still some work I'm trying to do to polish the library. There's still some issues I'm trying to support and some of the ways I want to support accessibility checks, which I'll talk a bit about later. So let's see how it works, or just in general to show an example of what it does. What Ally does is, what Ally has at its core is the report class, which is just a simple Kotlin class holding the parent ID, parent type, and some of the reports for the current layer and the next or the future child layer reports. What's important to notice here is that each report can have a list of child layer reports for the future layer, which means that, for example, if you have a constraint layout and that constraint layout has 3 other constraint layouts, it will have a list of future reports for the next layer for all of its children, because the general UI hierarchy in Android is a tree, meaning that you can have as many layers as you want, and you can go as wide in a tree as you would like, or as deep as you want. So it's really important that we do this in a recursive way to get all the reports and all the issues in check, instead of just scanning some of the, let's say, the issues in the first layer. All right, it's important to scan everything. It also has a next level report, which is just a single report, and this is a way for me to, after doing a recursive search of all the issues, I flatten every single layer into a single next level report, which gives me a way to have a linked list instead of a tree when it comes to printing out the data. And we'll see about that in a minute. Every view report can have, again, its parent's ID and type, and it's also the view ID and type that you're scanning. So, for example, if you have an image view within 3 layers of your application or your UI screen that has an issue, it's really important to know that what the ID and what type of the view you have an issue on. So if it's an image view, and in which layer and which parent it is, which ID of the parent it is, so that you know how to find that issue and fix it, right? It also has a list of view report items where each view can have multiple different issues. So an image view might be clickable as well as showing an image. So it might have an issue that it doesn't have any kind of description. And it also might have an issue where it's just too small to be clicked, right? So it can have multiple different issues and multiple different reports we have. And each report has an issue type, what the actual issue is, and what the fix suggestion is. LI also has these things which are called view scanners, which are just general objects which go through the hierarchy of the views and then scan each view specifically and giving a list of those view report items. So this can be general view scanners, this can be text view scanners, image view scanners, and so on and so forth. So different scanners for different types of views where you can find different types of issues, of course. And this is an example for one of the general view scanners, which basically checks if the view is big enough for its touch area. So if it has any kinds of listeners, and if it has any kinds of listeners and is too small, then it gives you a report saying, hey, this view is hard to touch. The view area is not large enough, either to touch or click, depending on the listener you have, or just in general to do any kind of interaction. And the suggestion might be that you make sure that the views are at least 48 dp large, which means their size and their padding, because padding comes into the touch area of the view, right? So this is an example of what a view scanner might do. As I mentioned, there are different ones for text, for images, and for general views, and also edit text, which are like a specific type of item. Here are some of the checks that I have in the library currently. So one of the things that are really important for people who suffer from any kind of color blindness is that you have a good enough contrast for your text. This means that the color of the text and the color of the background must have different types of luminance, which is the value of the color, basically, which shows how bright or dark the color is. And these contrasts are either 3.0 or 4.5, which is like a constant. And basically, there are different types of views that you can show in your app. There is large, let's say large text, or like text that has either bold styling, bold weight, and is at least 14 points in size, or views that are just not large, or like normal text, which is at least 18 points in size or higher. So there's a lot of different combinations here, but basically these are checks which tell you if the text contrast is correct or not. And the actual contrast is being calculated through the system, where you have the option to fetch the luminance of every single color and every single background color you have. And this is one of the functions that actually scan the views. So it fetches it gets the current view group, which might be the root layout or one of the nested layouts within those within that root layout. It fetches its children, its nested layers, so nested children, and the simple views, and then it basically generates a report for every single for the current view, and then every single layer if there are nested layers. Otherwise, it just returns null child layer reports, and then it gives you the idea that it's actually the last nested layer or layout in the layer, so to say. It does so recursively, so it calls scans view recursively, and then what you get basically is a tree structure, which I'll kind of show in a minute. So let's say we have the current structure, which is a single constraint layout, 2 layers of frame layouts and relative layouts, which has another linear layout as another layer. And all of these views can have, or containers and layers can have any number of arbitrary or simple views, such as text views, images, or something else. If we were to run Li against this structure, against this hierarchy, we will get a similar report to this. We will get a single report with view reports of the text view. We will get 2 nested reports which have the text view and image view reports, and then another nested report for the linear layout for image views, text views, and so on and so forth. This is really complex to visualize, I would say, if you have complex layouts. It's also really complex to print out as, as a person who's writing the algorithm for these things, because it's really hard to find a good way to show this in text, and also a good way to develop the code for this when it comes to printing it out. So what I did was I flattened every single layer to a single report, as I mentioned before, to a special or like a different function, different algorithm, which gives me a similar report to this. So I get the report for the first layer, first layer of the layout, for the second one, and for the third one. You can see here that the first and third layers actually refer to the parent of the view report, so where the view reports or where the issues are to be found. The second one has an NA, or not available, ID for the parent, because there is no single parent. There are multiple parents which are, so to say, condensed or consolidated into one single layer report or one single view group. Which basically means that I can't really, or I could technically say that this is a composite from multiple different types of layouts. But what I instead do is I store the actual parent ID, the parent type, within each of the view reports. So it doesn't really matter what the ID is for the report layer, right? Because you can still find those views as long as you know that they are in the second layer and they come from a specific parent. So does it actually work? Well, there's a lot of different things that you have to think about accessibility, and I'll expand on this a bit in the moment. But if we were to run Li and all the accessibility checks through any of the applications, this is one of the applications one of the test applications I ran it against. I got this report, which is a report of a single layer where the parent ID is not available because it's the root ID, or the parent ID of this root layer is the actual Android root view, whatever it is, which is why I don't really show its ID. It doesn't really matter. The view reports that I get is the circle image view with no ID has an issue. It's located within the swipe container, which is a swipe refresh layout. And the issue type is that it's missing a content description, or it doesn't have a valid content description. So for example, if you have image, quote unquote, and photo, quote unquote, within your content descriptions, that's not valid because it's redundant information. And obviously, if it's an image view and it has a content description, it's either an image or a photo, right? So these should be more concise and more descriptive. And that's what the suggestion is. The same goes for an empty icon, which I have within the same layer. And the idea of that view is empty icon. It's located within empty content, which is a linear layout, and it also has the same issue where it's missing or has an invalid content description. So this is kind of what the structure looks like, and it can be much more complex where it has multiple different layers and multiple different reports, or the same view can have multiple reports on its own. So there's a lot of things that's going on, but generally it works and it gives you an idea what you're missing or what issues you have. These reports are textual, so this is completely just basic text, and are located in your app's private or whatever you want to call it, your app's internal storage. That's more like it actually, within the application, so or within the device. So you can just run the application or just connect the device or emulator if you want to your Android Studio and use device file explorer, so you can just find this file and then look at all the issues you might have in terms of accessibility. Now, there are some issues when it comes to scanning accessibility and just doing analysis of it. It's not black and white. It's not something that you can say, hey, this is messed up, or this works, or hey, this doesn't work, it should be improved, and this is perfectly fine. Because it's one of those things where nothing is, I would say, perfectly fine, and nothing is fully broken, so to say. And to clarify on that is, some of these views that I showed in the previous example where they have issues might not be important for accessibility. So there's this thing where, accessibility becomes not just a rule, or it moves from being a rule, something that's strict and gives you instructions on how you should do this every single time. It's instead of a guideline. And I have a specific example here. This is the Discord server, which is again public, and you can just join it, which for our website, for Rebellion.com, and for our general community, where you can just ask any kinds of questions in terms of Android, iOS, Unity, Swift, whatever you want actually, and just hang out. And this is the example of general chat application, right? It's not specifically chat, it's Discord. It has multiple different features, but this is a chat screen for the most part, right? And if we analyze the message I sent, which is just a simple message, asking how everyone is doing on this fine Friday, which is like an older message because it's not Friday. You can see that there are a couple of different elements here. There's this image that shows me as as my avatar, whatever you want to call it. There's my name, the timestamp, and the actual message. But if you're looking at, this might sound wrong, sorry. If you want to put yourself in the shoes of a person who has full visual impairment or very, very hard visual impairment, those people won't be able to see the images, right? So what people with visual impairments do is they use something called either like gesture navigation and focus navigation and screen readers. So if you were looking at these images, what would you put as content description for these images? You can't really, you could describe me in words, but it might be very subjective. One person might say that I have like light brown hair. The other person might say that I have brown hair. Which of these is correct, right? This is very subjective, and more often than not, it doesn't really give you any valid or like any useful information, because I guess that in a chat application, if you know you're talking to me, it doesn't really matter what my image looks like or what my profile avatar is. It's more important what my message is and when I sent it or who sent it, right? So this image is not actually important for accessibility, but Ally or my library or any kind of other accessibility checks you would have in Android Studio or other different applications would actually tell you that this is a view that's missing a content description if you're missing it. So sometimes accessibility is not completely strict, and you should find a way to think about those things. And there are system checks that can help you, which there are some checks that give you an idea if the view is important for accessibility or autofill. But these are all also XML flags, which you can set to false, which means that essentially you can help the system, but also this lets you to ignore entire accessibility checks and just have whatever kind of accessibility support or none if you don't really care about it, right? So one of the things that I'm kind of struggling about my library is, should I incorporate these accessibility checks or these system checks in my library when I scan the views? Or should I just ignore them and force accessibility checks no matter what the view is? On one hand, if the person is using my library to help their applications be more accessible or build more accessible applications, they are probably not going to ignore accessibility issues. They're going to add the is important for accessibility flag as no for only those views which are not important. But then again, someone might abuse it. So, it's really hard to develop these things as a single person, which is why I'm, just looking for opinions of how things should be done. And if you have any kinds of opinions, you can share them with me. Also, you can, try to help out with the library by joining, GitHub and just trying to help out in terms of development. So this basically means that you can disable ally checks whenever you want for any view through the system checks. So I'm still trying to debate whether I should add those accessibility checks or just provide warnings maybe, or just do just provide issues and force accessibility checks. And I'm kind of at a crossroads, so let me know what you think about that. So one of the next things I want to do for the library is I want to test it across multiple types of applications, because there are different types different ways you can build your UI, different things you can use for your UI development. You can also use older API levels, older than 21, which is kind of what I use for the standard. I could make it more backwards compatible, or may just stick to 21. I'm not entirely sure. We'll still have to see if I'll still have to see if it makes sense. And of course, I want to add more quality of life improvements to give you more analytics, more LI handling. Maybe give like a specific, or you can provide a specific view scanner for your custom views, or maybe you can opt out of some checks or opt into different checks, or just a lot of different analytics that I can add to the library that I still have to see if this is something the users want. Users, I'm not sure who it actually is, but you can be one of them. And if you want to discuss accessibility or my library, or just any kind of open source collaboration with me, you can find me on LinkedIn, Twitter. You can find me on my official profile from the company on the ravenlink.com website. You can ping me through Gmail, or you can just find me on GitHub, Sessionize, or just our Discord chat. So you can just find me on many different social media networks and discuss these things with me. And if you want to help out with the development of the library, just let me know and we'll work something out. So thank you for joining my presentation and for listening to. I'm not sure how many people are actually here, but to all of you who are, thank you for joining. And are there any questions? Okay, there are questions, so I'm not sure if I should just go through them one by one. So in terms of the Google Play Console pre-launch accessibility report, how is it different or better compared to it? One of the things, I'm not entirely sure how the pre-launch accessibility report works, but one of the things that or Ally does is that it runs in the runtime, meaning that if you have any runtime checks that add accessibility, any kind of thing that actually, if you load the data from a network and you add some flags, accessibility flags through the runtime, but you don't have them developed or defined in the XML, you can instead get those reports, even though you might not be defining them in the actual layout. So it does so in the runtime, and it gives you a runtime kind of a help where, as you're going through the app, as you're developing the app, it will give you those issues you might have. You can fix them along the way. So it's one of those things that you can just include at the very beginning of your development cycle and then use until you actually push the application out, instead of doing like some checks before you actually launch the application, or like some last minute checks and then having to fix all of these issues. So it's a more iterative approach. It's a way to include the reports and scanning as you develop the app, instead of just when you're done developing and then have a little bit of time to include the accessibility checks. I hope that kind of answers your questions. Do you recommend we still use this even if not in 1.0 stage? What are the issues? So the issues, or the reason why it's not in 1.0, and is because, for one, this is my first library overall, and I'm not entirely sure what the 1.0 version is going to be. Will I be happy with it as I add the quality of life improvements, as I add some other checks, some system checks, or opt-in analytics, stuff like that? I'm not entirely sure what I want to have as a complete 1.0 that's going to be, so to say, production ready. So I don't have any kind of idea of what's going to be 1.0. Those are kind of the issues. There are some other issues where, as I mentioned, I'm not sure if by forcing the accessibility checks, I'm going to do everything in the optimal way, because you might tag some views that they are not important for accessibility. So I still have to figure out that small thing where I'm not sure if the library is doing what it's supposed to, or like doing the stuff in optimal way. In terms of, do you want to be annoyed by my force checks, or do you want to be able to just ignore checks and, I wouldn't say be a bad developer, but not follow the accessibility guidelines as you would. So I would say that, I would recommend that you just throw it in your application as an extra tool that helps you out in terms of scanning the application and, enforcing some of the accessibility rules. I wouldn't say that there are any performance issues, because I've been running the application across complex views, across complex applications, and there haven't been any kind of downsides or performance impacts so far. The scanning is pretty simple, pretty straightforward. It doesn't do any complex checks. It's mostly using the views that are already in memory, so it's very fast to fetch those values and compare them. So there are no performance issues, which kind of also answered the next question, I would say, or at least not no performance issues that I have found so far. I haven't found any. So do you use the same detection checks, recommended fixes as the Google Accessibility Scanner? So yeah, I'm trying to follow the actual documentation and the actual guidelines from Google. So yeah, I'm more or less using the same checks, detection as the Google Accessibility Scanner. Though I'm doing everything manually through code, I'm not entirely sure how that library works through things. So it might be more accurate to use Google Accessibility Scanner. But it's much easier to use than that, because you don't have to run an extra application. You don't have to give all the permissions, take all the screenshots, and then manually go through every single screen. You can just get a report saying, hey, these things are kind of faulty and you should be able to fix them, right? Thank you very much, Greta, for so far. Thanks for that. Are you planning to add a UI element like similar to LeakCanary, like a dialogue? So in terms of that, to draw something extra, or like how LeakCanary does is it runs an extra process which runs alongside your application, installs that application, LeakCanary application, and then it gives you a report to similar to what LeakCanary. So yeah, sorry. It gives you a report in an extra application that you can go through and like use as a standalone application. As I mentioned, I haven't developed any libraries before that, which are a bit more complex. So I'm not entirely sure how to build that, which is why I'm looking for help. And if anyone has any idea on how to do that, I'll be definitely interested in adding some of those things. So having an extra process that does extra things to offload the actual scanning and everything in case the scans become a bit more complex, and just to show a nice UI saying, hey, we're scanning the library, we're scanning your application, just wait for a couple of seconds. I do have like a small toast now which says, hey, there's nothing to report if you don't have any issues, or logging report if you do have an issue. Which means that basically, you'll get a small notification, a small toast saying, hey, there's something that's being scanned, there's something that's wrong with your accessibility setup, so you can check out the report and see what that is. So I do have some small bits, but I do plan to add some more complex things, which I currently don't know how to build, and I'm just doing or trying to research much more and trying to get help from others. I assume this can be built as a build variant, as having the report generated on production builds could lead to security issues. So yeah, currently the setup is very simple. You just call li initializer start, which is a simple function that connects your application to lifecycle callbacks, or your application's lifecycle callbacks to my library to scan things. In terms of security issues, yeah, it can happen, but basically what you can do is you can just like add an if the build is in debug, you can install or set up the library. Otherwise, you can just kind of exclude it. And yeah, the idea in the future is to build it as a build variant, as something what LeakCanary does as a no-op or like production no-op, whereas it has a debug variant where you only compile it in debug, and then you can add that library only in debug builds instead of release builds. So it will help both. It doesn't include that library in production builds, which is a good thing for just overhead. And it also doesn't cause any security issues in terms of scanning stuff, so no one can actually attach themselves to the process of me scanning stuff. So it's more secure in that way. So yeah, this is one of the things that can be built as one of the things that can be improvements, and definitely something that I'll look into in the future. And the last question is, are there any ways to check accessibility of embedded web view? So I'm not entirely sure, because WebView is actually rendering stuff within itself like a browser. So essentially, it's a problem because are we scanning for accessibility things within the Android ecosystem, or are we scanning for web accessibility guidelines? Because they are mostly the same, but web development has different types of flags, different types of attributes they use to add accessibility, which means that effectively I might not be able to scan those flags as you might be using one type of CSS or any kind of attributes or something else. So I'm not sure if there's like a good way to scan through embedded web views, but I'll try to look into that. That's a good question. And I think those are all of the questions.
Yes, so
yeah, yeah, I was going to do that, but so I'm not sure if there are going to be slides shared. I'll just share my links to the organizers, and then you can take a look at the slides and all the links that I gave in the end. Once again, thank you for joining my session and listening about my thesis project and something that I've been working on in the free time. Hopefully, we'll have more free time to work on it in the future as well. If you want to just chat about the library and just ask me any questions or even work on it, you can just ping me through any of the links that I'll provide. And once again, thank you for joining, and I'll see you later. I'll see you all in different sessions.